Okay, so today we're going to be continuing our session on permutations. Okay, and I'm going to just share this screen with you all. And just to recap a little bit on what we have been talking about, okay, when it comes to permutations. First of all, we were talking about the multiplication rule, where if there are two things that will happen one after another, okay, there are successive events, okay, that happen almost at the same time. Okay, and if one way can happen m number of ways, and then the second one can happen an n number of ways. So the operation that we need to talk about is multiplication. Okay, and remember, it must be successive events that happen almost. It's either one after another or they happen at the same time. Okay, they cannot be two totally different events because the first method will the first event will affect the second event. Okay, that's the basic understanding of this. Okay, if the first event affects the second event, then we use multiplication. But if the two events are totally unrelated, which you will see in a while, okay, then we don't use multiply, we use plus. Okay, so that's the first thing we learned the last time. The second thing is we learned the very basics of permutation. Remember, permutation is finding how many arrangements there can be. Okay, and if you, let's say you have three numbers, 1, 2, 3, you want to arrange these three numbers, you want to find out how many arrangements there are possible. That means you want to permutate all three. You want to arrange all three. Yeah? So we use 3 factorial, okay, or n factorial like in this case. Okay, kalau kamu ada bilangan yang sama dan itu juga yang kamu mau susun, so you just factorial it. Okay, otherwise known as NPN. Okay, but the third thing that we learn is if there is a certain number from a bigger number. Contohnya, you have 5 coins or you have 5 people, but you only want to choose 3 and you want to arrange the 3. So you can choose 1, 2, 3 or 1, 2, 4 or 1, 2, 5 or 2, 3, 5. You know, there's so many ways that you can pick and arrange. Okay, so basically that's the understanding of permutation. You pick and then you arrange. So if you pick everybody, then you just factorial. Okay, if you have everybody and you want to pick everybody, you just factorial. But if you have a certain number of people and you only want to pick some, okay, then we use NPR. Okay, this is the long form of it, n factorial over n minus r factorial. Okay, otherwise, you can just use your calculator and press NPR. So we spent a significant amount of time last week now trying to figure out where the factorial sign and where the permutation sign is. Okay, so for today's class, I hope you have your textbook with you. I hope you have your calculator with you because we're going to be diving into the more common questions. So far, everything that we've answered is not very common. Okay, it's too simple to be common. Okay, all consider 1 mark question. So it's too simple. Okay, now we're going to go into the slightly more complicated ones. Okay, which involves conditions. Okay, so for example, in this case, so you have permutation of n different objects under certain conditions. Okay, sorry, there's still people coming in, so I'm going to learn for a while. Okay, so what we're going to do is we're going to take a look okay, at how this can be. So, for example, question 26. Sorry. Okay, for example, question 26. How many code words can you form from the letters T-A-K-E-S? Okay, over here. So you have this is the 5 letters you have, T-A-K-E-S. So you have 5 letters. So the question is, how many code words can you form from all 5? So basically the question is asking you, if you have 5 letters, you want to permutate all 5, how many code words can you form? How many arrangements can you form? Okay, notice that they don't use the word arrangement, they don't use the word permutations very specifically, very explicitly. Okay, dia bukan secara langsung dia akan bagi tahu kamu berapa pilih atur yang kamu boleh dapat. No, okay, you have to figure out that, oh, okay, when they say code words, it means arrangements. How many arrangements of code words can you form from the letters of the word T-A-K-E-S? So we have 5 letters and we want to permutate all 5. So the answer will be, if you want to permutate everything, it will just be 5 factorial. Okay, then you figure out the answer on your own. Okay, and you must remember that if we have all 5, and we want to permutate all 5. Okay, if you type out the answer in your calculator, you'll get 120. Okay, which means that whatever question that comes after this, okay, the answer cannot be more than 120. Okay, because the maximum number of arrangements you can have, okay, if you're going to permutate all 5, okay, is 120. If you're going to permutate all 5. Okay. Next question. How many of these words begin with a vowel? Okay, this is where it gets complicated. So now they're putting a condition. Mereka meletakkan satu syarat sudah di sana. Dia cakap, out of the 5-letter words, okay, satu code word yang 5 huruf, the first one must be a vowel. Okay, and then the rest I don't care lah. Tapi dia mesti, the first one is a vowel. So what I would usually do, okay, in this case, is I would specify lah, okay, kalau ada 5 huruf, so it'll be first place, second, third, fourth, and fifth. Okay, and then the first one, okay, must be a vowel. So let's take a look. Out of T-A-K-E-S, T-A-K-E-S, okay, sorry, somebody is still coming in. Okay, out of T-A-K-E-S, which one is a vowel and which one is not? Okay, so these are all basic things that you need to know. What is vowel, what is non-vowel, what is a non-vowel is called a consonant. Okay, C-O-N-S-O-N-A-N-T. Vowel, there's only 5 vowels, A, E, I, O, U. Okay, the rest of it is all called consonants. Okay, so please know this lah. Okay, dalam bahasa Melayu it's still huruf vokal dan huruf consonant. Okay, it's still the same. So in our case over here, we find that there are 2 vowels, okay, which is A and E. Okay, so think about it. There are for this particular place, there are 2 vowels, but you only have place for 1. So this would be 2P1. Okay, 2 vowels and you only have place for 1. Okay, so this would be 2P1. Once you have put in the vowel, contohnya lah, let's say I've already put in A, okay, how many letters do I have left? I have 4 letters and I want to permutate all 4. Termasuk yang huruf E. Okay, so this will be times 4 factorial. Okay, and this will give us the answer. I think it's 48. Is it 48? Can somebody please check for me? It's either 48 or 128. I'm not really sure. Okay, it should be 48 lah. I didn't write down this answer. Is it 48? Sorry, but anyway, that's basically how it is. Okay, if the first one can only be filled by a vowel, then you need to think how many vowels there are, and you can only put in one place. So it will be 2P1, and then the rest all I want to permutate it. So selebihnya adalah 4 factorial. So the answer will be 48. Notice that this answer is not more than 120. So we are safe lah. Okay. Secondly, okay, and this is an even more strange condition. They cakap begin with a vowel and end with a consonant. Okay, so I'm going to do this up here. Okay, so we still have the same thing. We still have 5 places. 1, 2, 3, 4, 5. Okay, we settle all the conditions first before we do the rest. So the first one is begin with a vowel. How many vowels are there? There are 2 vowels. How many places can we put the vowel in? Only 1. So 2P1. The last one must be a consonant. Daripada 5 huruf ini, T-A-K-E-S, which are the consonants? The consonants are S, K, and T. So for this last place, is 3 consonants. Kita mau pilih satu sahaja. So this is how many ways we can pick 3 consonants if you're going to have only 1 place. Okay. Now, once you settle the conditions, then you look at the rest. Okay, ada 3 sudah dihitung. 1, 2, 3. So this will be just 3 factorial. Because tinggal 3 huruf, I don't care which letters go where. Okay, but this will be our case. And because all of this happens simultaneously, semua ini berlaku serentak, then we use multiply. Okay, we use the multiplication rule. Because bila kita sudah masukkan vowel di sini, ini akan terpengaruh ini. Bila kita sudah masukkan one consonant here, this one also terpengaruh. So that's why we use the multiplication rule. Okay, sorry. Okay, and then you will get the answer. This answer will be 36. Okay. So the difficult part, not to say the difficult part, the confusing part, okay, the confusing part about permutation is kita kena fikir secara logic. This is a standard 2-mark question now. Sorry, this will be a 3-mark question, sorry, because A and B. But this is a very standard jalan kerja. It just requires us to think logically. Okay, we settle the conditions first, and then only we put in the rest, because the rest all we have to permutate everything. Okay, ini kalau kita mau permutate everything, means we want to have all the 5 letters we permutate. Okay, but we have all these conditions. The first one must be a vowel, the second one must be a consonant. Okay, maybe at this point some of you are asking, why must there be conditions? Kenapa mesti ada syarat-syarat begitu? Well, I think that's human nature lah, you know. A lot of humans, I mean, we always like to ask, what if it is like this? What if it is like that? That's why lah. Okay, so basic human curiosity lah, okay, enables us to figure out these things logically. Okay, so yes, we have to accept the fact that sometimes there's going to be conditions. Okay, so we have to figure out, you know, how many arrangements there can be if you set a certain condition. Okay, so this is a basic explanation, okay, of if you want to permutate everything, okay, and then you know they start to have this kind of conditions. Okay, so what I want you to do is I want you to try to do question number 27 first. Okay, I'm going to give you about 20. I'm going to give you maybe about 3 minutes or 3 to 5 minutes. Okay, to try to figure this out. Okay, let's look at the question first. 27. Find the number of code words with their consonants adjacently placed. Adjacently placed means placed side by side. Okay, that can be formed from the letters of the word read and combine. Okay, so this is the condition. Okay, kita mau permutate everything. We want to have all the 4 letters for read and all the 6 letters. Sorry, 1, 2, 3, 4, 5, 6, 7. All the 7 letters for combine. Okay, but let's talk about read first lah. If we want to have the consonants adjacently placed side by side, means R and T mesti sentiasa bersama-sama. Okay, so try to figure out the working. How do you work this out? How do you work this out? And then after that, maybe in about 10 minutes, I will take a look at your whiteboard lah. Okay, if you think that you have figured out the answer, put your answer in the whiteboard, and then we'll see what happens from there. Okay, so yeah, take some time and do it. I'm going to pause the recording first. Okay, so everyone, let's come back to this. Thanks for your participation. So let's start with the word read first. Okay, so the problem is this. The consonants must be side by side. Okay, and since there are 2 consonants here, okay, so since they have to be side by side, okay, R-A-T-E lah, contohnya. Now, if I'm going to group these 2 as one, because this R and T cannot be split, so they have to be together all the while. So that gives me but the thing about this is there's 2 ways to do this. R here, T here, or T here, R here. So we're talking about a 2 factorial over here. Okay, and then if I group this as 1, okay, I'm going to change color. Okay, if I group this as 1, means I have 1, 2, 3 things that we need to permutate around. Okay, so this will give us 3 factorial. So my answer will be 12. 2 factorial times 3 factorial. 2 factorial because there are 2 consonants and we have to, you know, permutate them inside this one group. But because the consonants are together, okay, so I can group them as 1. And then the other 2 letters yang vowel itu kan is this one. So there are 3 groups altogether and I want to permutate all 3. So this will be 3 factorial. So 2 factorial times 3 factorial will be 12. I noticed that some of you did it other ways. It's totally fine. Okay, but the point is this. Whenever 2 things have to be placed side by side, it's always good to group them together first. Okay, when you group them together, it makes our this one much easier. But when you group them together, remember, inside the group itself, you also have to permutate, which is exactly what happens in this combine. Okay, let's take a look at the combined one. So combined, there are 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. COMBINE. Okay, so there's 7 altogether. And out of the 7, CMBN. Okay, CMBN is the consonants. So all these 4 have to be together. So CMBN, kalau saya mau permutate everything, this will be 4 factorial inside the group itself. Okay, outside the group, okay, that means the CMBN itu bila saya sudah arrangekan, and then I want to permutate with the I, O, and E. With the I, O, and E. Okay, with the I, O, and E, so this will be one group, then the 3 vowels, I, O, and E. So there are 4 groups altogether outside the permutation. So this will be another 4 factorial because we want to permutate everything now. So 4 factorial times 4 factorial will give us 5, 7, 6. Okay, and this is another way of looking at it. It's slightly different. I noticed that a lot of you did the way, because saya cakap, oh, okay, yang first itu kasih masuk ini. But this is slightly different. Okay, I wanted to get you to think about this. Whenever you have something in a situation that you have to place side by side, group them together. Okay, group them together and then permutate outside, which is the one I'm doing in red. But don't forget that inside the group itself, okay, inside the group of consonants, okay, I also have to permutate them, okay, which is inside the group itself. Okay, so now I'm going to test you again. I'm going to change this one. Okay, I want the vowels to be adjacently placed. So I'm going to ask you to draw this on your whiteboard again. Okay, use the same, use the same, this one. Okay, use the same words, okay, red and combine. Okay, but now I want the vowels to be adjacently placed. Okay, how would you do it? Okay, for the words red and for the words combine. Okay, see if you, of course, the answer will be slightly different, I think. Okay, but try and see that. Okay, use the same word red and combine, but now the condition is I want the vowels to be adjacently placed side by side. That means the vowels must travel together. No choice. Whenever they arrange, the vowels must be together. Okay, I'm going to give you 5 minutes to do this. Show your working on the whiteboard now, please. Okay, so now we're taking a look at this question now, question number 28. Find the number of 4-digit numbers with values greater than 3,000. Okay, so if there are 4-digit numbers, let us first set the placing. Place number 1, place number 2, place number 3, place number 4. 4 digits. Okay, tapi kita ada berapa huruf? Kita ada 5 huruf. 5 kah? We have 6 numbers altogether. Okay, we have 6 numbers altogether. 0, 1, 2, 3, 4, 5. So there's 6 numbers, but you only want to choose 4 and you want to permutate. Now, if there are no conditions, kalau dia tiada syarat, then it will be just 6P4 lah. Okay, but now the problem is there is a syarat. Dia cakap the number must be greater than 3,000. Okay, which means there is a condition for this first place. This first place can only be filled by the numbers 3, 4, and 5. And there's only one place. Okay, so this will be 3P1. Out of the 3 numbers, 3, 4, and 5, you can only choose 1 to go in here. Okay, so that's this one. Okay, and then the rest of it, okay, the rest of it, kalau sebelum ini, when we were talking about this one, we want to permutate everything, so it's just factorial. But now, because, okay, after you put one number here, let's say I put number 3 over here. Okay, how many numbers do I have left? I have 0, 1, 2, 4, and 5. And how many places I have to put in? I only have 3 places. So this will be 5 numbers. I only want to choose and arrange 3. I only want to permutate 3. Okay, so my answer will be this one, 3P1 for the condition. And this is the no condition one. Okay, so this will be 5P3. So 3P1 times 5P3 will give me the answer 180. Okay, so this is a slightly more complicated one yang doesn't really involve factorial anymore because you have a certain number but you only want to choose some out of the all. Okay, before this, this one is you want to permutate all, so it doesn't matter. But this one is you only want to permutate some. Okay, when you want to permutate some, then you need to figure out how many that you can choose. Okay, and what the conditions are. But the general rule still applies. Okay, settle the condition first. Then the rest of it is either factorial or is NPR. Okay, means you daripada semua kamu hanya pilih beberapa saja, and then you permutate them. Okay, so this one, this next condition, how many of these numbers are divisible by 5? Okay, divisible by 5 means boleh dibahagi dengan 5. Boleh dibahagi dengan 5 means what? So this is where all the logical thinking comes in. I'm going to change color. So we still have the same one, 4 numbers. Okay, but this one over here can only be 3, 4, and 5. Okay, so sorry. So this can be 3. Okay, this is the problem. It can only be 3, 4, and 5. But the problem is your back number must be divisible by 5. Okay, let's settle the back first. Over behind here, it can be either 5 or 0 because these numbers are divisible by 5. The behind number is number 5 or number 0. Okay, so here we're talking about 2p1 now. Okay, but this brings a problem to us. Okay, and this is where this question becomes difficult. Kita boleh letak nombor 5 di sini dan kita boleh letak nombor 5 di sini juga. You see the problem here? You can put number 5 here and you can also put number 5 here. So the number 5 actually is in both conditions. So that gives us a problem. Okay, and if that problem arises, then you will have to split everything. Okay, you have to consider every single factor first. Okay, so what I'm going to do is I'm going to say, okay, I can put 0 and 5 here, but over here I can only put number 3 and number 4. Okay, I don't consider number 5 yet. Okay, so if I can put 0 and 5 here, this will be 2p1. If I can put 3 and 4 here, this will also be 2p1. Okay, so once I put one number here, I'm left with 2 more places. And how many numbers? I have 4 numbers. Okay, so this will be, this whole section will be 4p2. Okay, I don't care what the numbers are anymore because ini tiada syarat. Ini je yang ada syarat. Okay, the syarat is behind number must be either 5 or 0. So it's 2p1. And then the front number is either 3 or 4. Okay, and then this is 2p1. So this is set number 1. Okay, but the problem is the other set happens because this number must be number 5. Okay, I'm going to change color to show you the other set. I'm going to use blue lah. Okay, so this is 1, 2, 3, 4. Now saya cakap nombor depan di sini mesti 5 because I already considered 3 and 4. Kalau nombor di depan sini 5, then the behind there's no choice, there's only 0. I can only put 0. Okay, so because there's only one number you can put here, so this will be one way, this will be one way. And then over here, once you have put the 2 numbers, this will also be 4p2. So 4p2 times 1 times 1. And because the black set and the blue set are not dependent on one another. Okay, so this set of answers plus with this set of answers will give you the final answer. Okay, because this set is not dependent on this set and this set is not dependent on this set. Okay, since they're independent of one another. Okay, so this one, hold on, Timothy. Okay, this one and this one we will plus together. Okay, yes, Timothy. You can unmute yourself, I think, and you can ask me if you want.
Sir? The black one, I don't understand. Yang in the middle, why there are 4?
Okay.
Because so we take back, we take 2.
How you take what,
I mean, because front already 3 and 4 kan, and at the back already 5, 0.
3 or 4. If the front, let's say saya sudah letak either 3 or 4, I already put one number lah. And then the back is either 5 or 0. So saya sudah letak
Oh ya kan. Oke oke.
4 numbers left.
Oke, get it.
Okay, thanks for the question.
Oke, kita bisa.
Ambil satu nombor je. Yeah. Okay. But it's a little, I don't know, it's a little bit like Sudoku lah. Okay, like, you know, what are the numbers that can go here? But you can only actually put one number. But because there are two possible numbers to put here, so with two permutate one, two kita pilih dan kita atur satu. Okay, but the complicated thing I would probably think lah. Okay, the complicated thing that will probably arise is that you need to consider that this number 5 is a very big problem. Because, okay, a common mistake is to put this one, 3P1 over here. Okay, and then you forget that actually the number 5 can also go behind. And that's where the complication arises. This number 5 can go into group 1 or can go into group 4. That's where the problem arises. So when that happens, if you find yourself in that situation, then this is a much bigger box that you have to think out of. Okay, you have to first consider that I cannot put number 5 here. I must put number 5 here. And then after that, you consider another situation where I can only put number 5 here and then the number 0 goes behind. So when you do this one, 2P1 times 4P2 times 2P1, okay, you get a certain number, which, sorry, I didn't calculate this. And then 1 times 4P2 times 1, okay, you get this certain number. You will find that the final answer is only 60. Okay, you multiply this, plus you multiply this, and you get the final answer is 60. Okay, so don't worry if you cannot get it this first time. Once I put this up on YouTube, watch this video again, watch this section again. Okay, this requires a little bit of this. Then when you do your questions in the module for your practice, okay, take it slow. Okay, logical thinking doesn't happen very fast. Okay, yeah, I know it sounds very weird. Okay, logical thinking is a very slow and very painstaking process that you have to really perah otak. Okay, and this is as you can see, actually the working is like nothing, you know. It's 3P1 times 5P3. Tapi masalahnya is macam mana mau dapat ini 3P1 and macam mana mau dapat ini 5P3. That thought process is the thing that makes this chapter difficult. Okay, the jalan kerja is actually very easy. Okay, there's no complicated maths involved here. It's just a lot of complicated thinking. Okay, so whenever you face with permutation and later combination type questions, be ready with this kind of complicated thinking because that is the skill that you need to learn over here. Okay, so now I want you to try to do this first. No, you know what? I'm going to do A and B first. I want you to think about this later. Okay, so find the number of ways in which 4 men and 4 women can be seated in a row of 8 chairs. So you have 8 people and you have 8 chairs. So that's very simple. Okay, the answer for question A will be just 8 factorial. Because kamu ada 8 kerusi dan 8 orang, kamu susun semua. So no problem. Okay, but if there are 9 chairs and there are only 8 people, it means that there's going to be 1 empty seat. Okay, so how many ways can you permutate them? This would be 9P8. Because there are 9 chairs, you only want to choose 8 chairs to be this one. So it's 9P8 lah. Okay, so the answer for this will be 40320 and this will be 362880. Okay, I'm not going to waste time with this because this is covered in the previous section. But now we want to talk about the conditions. Okay, in each case, in the case of the 8 chairs and the case of the 9 chairs, the first 2 chairs must be occupied by men. Okay, how many ways can the 8 persons be seated? Out of these 40,320 ways, kalau the condition is the first 2 chairs must be men. Okay, I don't know why. This is not a sexist question, okay, but it's just the condition is that way. The first 2 chairs must be men. Okay, try to figure out how many arrangements or how many ways can we arrange these 8 people. Okay, remember, if the first 2 chairs are by men, means you group them together. Don't forget to permutate inside. Okay, but you also have to think about the outside. Okay, I'm going to give you 10 minutes to figure this out and then write out your answers in the whiteboard. Okay, pausing recording. Okay, so I'm going to show some of your workings. Don't be embarrassed by it. Okay, I'm just going to show some of your workings because I noticed that some of you, your thought processes are slightly different. Okay, I'm going to start with this one. mana ini? Kenapa dia padang? Okay, I'm going to start with this one. Okay, I'm going to start Aidan's one. So Aidan wrote here is 2p2 and then times 6 factorial. This 6 factorial is correct. Okay, because once you put the 2 men here, then we don't care, the rest of it is men or women. So there are only 6 people left. Okay, so you 6 factorial is correct. But this 2p2 means there are 2 men and you only want to choose 2 is not correct. Okay, it should be 4p2. Because there are 4 men and you want to choose 2 first. And then yang lain itu adalah this one. So actually it should be 4p2 times 6 factorial. Okay, so this is almost correct. This 6 factorial is correct because after you put the men there, then you don't care. The rest of men, women, just factorial all of them. Okay, so that's a good one. But this 4p2 yang kamu kena perbaiki. There was another one that I saw, but I think this person go and padam already. Yeah, it's Spencer punya. Okay, it was Spencer and Kelly's one, but don't know why they go and padam. Okay, another one that I want to highlight is, okay, I'm going to use Ethan's one. Okay, so Ethan has got the first one correct, 4p2 times 6 factorial. Okay, because remember, there are 4 men and you only want to choose 2 men first. That's the condition. Okay, this one, 4p2 times 7p6. Okay, so it's almost the same condition. First, you put the 2 men, but then the problem is you have 7 places and you only want to fill in 6. So like, kerusi ketiga sampai kerusi ke-9, there's only 6 people. That means there's going to be 1 empty chair somewhere. So this will be 7p6 because you have 7 seats and you only want to choose 6 seats for the people to permutate in on. Okay, so this is the answer for the second one, 60480. Now, one thing that I saw just now, which tidak keluar, there, this one. Okay, thank you, Kelly, for putting it back. Okay, this is an interesting approach. Okay, you put 2 factorial, and then after that you put 7 factorial. Okay, I only want to mention that, okay, of course the 2 factorial is halal because there are 4 men, and you only want to choose 2. So memang kita tidak boleh pakai factorial. But why can we not use 7 factorial? I noticed that quite a number of you, you use 7 factorial. Because the condition say, this first one, dia tetap dalam berpencen tidak boleh kena ubah. Dia mesti di depan. Kalau kita letak 7 factorial, if we put 7 factorial, means this group 1 can be here, can be here, can be here, can be here. We don't want that. Okay, yang kita mau berubah-ubah is dari 2 sampai 7 saja. Orang kedua sampai orang ke-7 saja boleh berubah. That's why it should be 6 factorial and not 7 factorial. Okay, quite a number of you actually use this 7 factorial. Okay, and I understand why, because from the previous question, we put 7 factorial. But we must remember that this condition, syarat yang diorang bagi ini, these first 2 mesti di depan. They cannot move anywhere else. So ini tetap dalam berpencen. So we don't, kita tidak melibatkan diorang dalam susunan. Ini saja. This is the only one that we permutate. Okay, so it's 6 factorial. Okay, so thanks for the feedback, guys. It helps me to know also what is your thought process. Okay, but like I said, okay, this takes quite some time to get used to. Okay, before we go into the next question, I just want to ask if any one of you have any questions so far, because after this, we're going to go into the slightly more difficult questions, also from the textbook. Any questions? Okay, if there's none, let's continue. So I want to take a look at a couple of questions from the textbook. Some are easy and some are difficult. I probably have time to do 2 easy and 1 difficult one. Okay, so I'm going to start with this first. I'm going to start with question number 35. I think 35 is the easiest. Okay, so 8 students are selected to proceed to the finals of a poetry recitation competition. Okay, this one seems very long, but I tell you, the longer the question, the easier the question, seriously. A draw is made to decide the order in which the students are to appear in the final. So kita cabut undi untuk menentukan susunan. This is a very typical situation. Right? You have a poetry recitation and you want to cabut undi to see who goes first, and everybody always wants to go last because they don't like to go first, yada yada. So find the number of different ways that can result from this draw. So you have 8 students and you want to tentukan the susunan. So the answer to this will obviously be just 8 factorial because you want to permutate everybody. Okay, so this is kind of a no-brainer lah. Okay, so the answer will be 40320 for 8 factorial. Lag. Yeah, my internet connection is unstable. Okay, let's see. Is everything okay? Oh dear. Okay. Wow. Somebody's trying to come in, bros. Okay. So 8 factorial, because there are only 8 people, you want to susun all 8 so that you know you have this one. So guys, there are 40,320 ways to determine who goes first, who goes second, who goes last. Okay, so the chances of you getting what you want is 1 in 40,320. Okay, it's pretty high. But this is where it comes in. Find the number of outcomes for the champion, the first runner-up, and the second runner-up of this competition to be declared. Berapa cara untuk kita mendapat champion, berapa cara untuk kita mendapat first runner-up, and berapa cara untuk kita mendapat second runner-up. Okay, so how many ways are there to get a champion? There's only one way to get champion. There's only one champion. So how many people altogether? So there is 8 people and you only want to choose one champion. How many ways to find the runner-up? There's only one way to find the runner-up. But there are how many people left? There are 7 people left. And likewise, when you have the second runner-up, this will be 6 people left because 2 people have already become champion and first runner-up. So it's pilih satu saja. So this is the answer. 8P1 times 7P1 times 6P1 will give you 336 ways. There are 336 ways. There are 336 ways to determine the champion, the first runner-up, and the second runner-up. Okay, so if you take a look at this, actually, as I said before, the working is not difficult. What is difficult actually is understanding the question. Okay, memahami soalan itu sebenarnya is the battle that you need to fight when it comes to questions that have to do with permutation and combination. Okay, what if you ate P3? What do you think? Can? I think you get the same answer. Actually, that's true. Yeah, you get the same answer. It's also 8P3. Okay. Yeah, I think it is still possible. Can. You can use 8P3 also. It is not wrong. It's a different thought process, but it is not wrong because the 3 places already sudah kena tentukan. Then, but just make sure that you don't permutate the 3 altogether. What if everyone is a winner? What? Everyone is a winner, then it's 8 factorial law. It's 40320 law. Because everyone is a winner, so you just what kind of winner you want to be? Or maybe there's just one way. All 8 are winners, right? So there's only one way because all 8 are winners. Okay. All right. Let's do another one. I'm going to do question 30. Okay, this one. So 4 prizes, a first prize, a second prize, a third prize, and a consolation prize are to be presented in an art competition. If 15 students are shortlisted to take part in this art competition, how many ways can the 4 prizes be presented if no student wins more than 1 prize? Okay, this is a condition that is very standard. There is no repetition. Means there is no student that wins the first and the second prize altogether. No, one person can only take 1 prize. Okay, and we find that for this, the answer is there are 15 students and you only want to pick 4 winners. So the answer is 32760. Okay. Again, I'm doing this question to show you that actually sometimes the long and complicated questions look at the jalan kerja okay, it's only 1 mark only. Okay, but it requires you to understand what the question wants. Okay, and yeah, and the reason why we choose permutation, later you will see the reason why we choose permutation and not combination is because it matters who gets first, who gets second, who gets third, and who gets 4th prize. Okay, the arrangement matters. That's why we use 15P4. For those of you who have already studied combinations, we don't use 15C4 because the arrangement matters. Or C, which we will look into on the next class, the arrangement doesn't matter. Okay. All right. Okay, I'm going to do a slightly complicated question, which is this question 31. Okay, so you have 8 chairs that are arranged in 2 rows of 4. Oh, sorry. Okay, 8 chairs that are arranged in 2 rows of 4 chairs each. Okay, so you have chair number 1, 2, 3, 4, and then you have 2. 1, 2, 3, 4. Okay, now a married couple, X and Y, together with 6 other persons, so there are 8 persons altogether. And in these 8 people, there's this married couple, which is X and Y, okay, are to be seated on these chairs. So, sorry, I'm going to label this as row 1, and this is row 2. Okay, find the number of arrangements of seating these 8 people such that, okay, condition A, X and Y are seated on the same row. That's condition B, X and Y are seated in different rows, and condition C, X and Y are seated together. Now I'm going to ask you to do A and C first, because the most difficult of this is actually B. Okay, I'm going to ask you to try and do it first. Do A and C first. If you have done A and C, you want to try B, go ahead and try B. Okay, so the first condition is X and Y are seated in the same row. They're either sitting in row 1 together, or not necessarily together, sorry, or they're seated in row 2 in the same row. They're not necessarily seated together. Seated together is C. Okay, so take some time, try it. We will come back in about 10 to 15 minutes. Okay, and then we will answer this question together. So show me your answers again, as always, on the whiteboard. Okay, so we're going to take a look at some of your answers. And actually, I want to ask some of you. Okay, I'm going to look at question C first. So question C is X and Y are seated together. Okay, and maybe I made a mistake of giving you all the answer, because when you figure out the answer, then you just like, main tembak saja. Okay, I'm going to ask quite a number of you are giving me the same. This one, 4p2 times 6 factorial, 4p2 times 6 factorial. I want to ask, how did you conclude this? How did you figure out that this is 4p2 times 6 factorial? Like, okay, look at Mikol's answer, 4p2 times 6 factorial. The answer is correct. Nobody is doubting the answer. I'm only doubting the jalan kerja. Why would you do 4p2 times 6 factorial? And then why is it different from the first question? A, 4p2 times 6 factorial, 10 times 2. Okay, the effort is not to get the right answer. The effort is thinking about it. How did you come to this conclusion that, oh, we must use this one? 4 tempat mau kasih masuk 2 orang. Okay, 4 tempat mau kasih masuk 2 orang is correct. Lepas tu ada 6 orang lagi kan? Okay. But, okay, if that is the case, then how is it different from this? How is it different from the first question? Because the condition is different. The condition for question A is that we don't care whether they're sitting, okay, we don't care whether they're sitting together or whether they're sitting apart. But in question C, it's very explicit. In question C, it says that they must sit together. Okay, so, and if you think about it, if you remember the previous questions that we did, if they must sit together, means we need to group them. We need to group them in such a way that they cannot be apart. Okay, and that's the thing that I'm not seeing over at your working. Okay, sorry, somebody is writing. 4 factorial times 6 factorial is also not correct. Okay, I'm going to start with question A. Okay, sorry, question C. Fine, question C. Now, if X and Y are seated together, okay, what I'm going to do is I'm going to group these two together. Okay, and this is already preset, this will be 2 factorial because there are 2 people and I want to have 2 people to sit over there. Okay, and then if you think about it, the rest of this, okay, 1, 2, 3, 4, 5, 6, okay, this can be arranged in a myriad of ways. So this will be 6 factorial. Okay, oh, sorry, hold on. Okay, 6 factorial. So these 6 people can be arranged different ways. But the problem is, these 2 people, they can sit here, they can sit here, they can sit here. So in row 1, there are 3 ways that they can sit. In row 2, they can sit here, they can sit here, they can sit here. There are another 3 ways that they can sit. So for me, for question C, this will be 2 factorial because of the married couple times 6 factorial because we want to arrange the rest times another 6 ways because these people can actually jump around from 1, 2, 3, 4, 5, 6 ways of this one. Okay, so this is the problem, we find that in most questions for permutation, if you get the good news is if you get the answer, then your answer is full marks lah. Okay, but if you don't get the answer, then your thought process is actually very important. Okay, we have to put these 2 together so they are one group. Okay, then the rest all I can permutate as I like. But the thing is, okay, why I cannot use 2 factorial times 7 factorial, which is what we did just now. Okay, let's say the 8 people, 1, 2, 3, 4, 5, 6, and 8, they're all in one row, and these first 2 must be together. Okay, so then saya cakap tadi, okay, kita group diorang sebagai 1, 2, 3, 4, 5, 6, 7. I can do it if they are in one row. The beauty of this question, okay, is that they are in 2 rows. So you cannot simply arrange them because these 2, no matter what, have to be together. And we find that if they are together in row 1, there are 3 ways they are together. If they are together in row 2, there are 3 ways they are together. So that's why we multiply by 6. Yeah, I know. This is an extremely difficult question because, this is like whole new levels of thinking. Okay. So, yeah. So, yeah, be patient. Okay. So that's why we don't use 2 factorial. If they're all in one row, then fine. 2 factorial times 7 factorial is definitely the right answer. Okay, but yeah. Okay, so for the first question, x and y seated in the same row. Okay, now if x and y are seated in the same row, I notice that all of you, sorry. Okay, I noticed that all of you, you did quite a number of you lah. Okay, you did it very well. Okay, so you see that okay, if they're in the same row, that means there are 4 places and you want to choose 2. Okay, this is the standard one because you want to put x and y first. Okay, and then the rest of it, I don't care how you permute it, so it's times 6 factorial. Okay, and then the reason why we times 2 is because there are 2 rows that these 4p2 can happen. Okay, they can be in row 1 and they can be in row 2. Okay, that's why we times 2. 4p2 because, okay, 4p2 and 2 factorial is different. 4p2 means ada 4 tempat duduk dan saya mau letak duduk x dan y. I want to put this x and y first. Doesn't matter whether they're seated together. Maybe x here, y here, or x here, y here. Doesn't matter. Saya mau 2 tempat dulu kena isi. Once saya sudah isi x and y in the same row, and then the rest of the 6 places, okay, the rest of the 6 places I can permute it as I like. So it's 6 factorial. But that is kalau kita letak diorang di baris pertama. Kalau kita letak diorang di baris kedua is another case in itself. So that's why we times 2. And that's how you get the answer 17280. Okay. Now the most difficult question for this is actually question B. Because question B, x and y are seated in different rows. That means we have to consider, okay, x di sini, y di sini, and then permutate the rest. Or y di sini, x di sini, and then permutate the rest. Okay, it's actually very long and very complicated. But the trick to this, the trick to understanding this is this. We need to figure out, let's say if there are no conditions at all, tiada syarat langsung lah. Okay, if there are no conditions at all, you have 8 people, you have 8 seats, so the maximum number of arrangements is 8 factorial. Okay, and 8 factorial will give you 40320. Okay, 40320. oh sorry, 40320. Okay, this is the maximum number of arrangements. Means whatever answer you get cannot be more than 40,350. So the first question that you answered is they are all seated in the same row, and you get 17280. Okay. Now in real life, they can only, and since there are only two rows, okay, thankfully there are only two rows now. Okay, since there are only two rows, there can only be two conditions. Either they're seated in the same row, or they're seated in different rows. Okay, so if you have figured out now that there are 17,280 ways for them to sit in the same row, that means the balance must be they're sitting in different rows, no? Because sama ada diorang duduk di baris yang sama atau diorang duduk di baris yang berlainan. There's no third option. Can you think of a third option? Cannot, because there's only two rows. So the answer for question B, the beauty of it is that when you have figured out question A, all you need to do is just 8 factorial minus 17280. Because the number of ways altogether is the maximum. Okay, and the maximum is divided into two different sets. Either they're seated in the same row or they're not seated in the same row. So seated in the same row is 17280. So you'll find that the total number of ways minus seated in the same row will give you the final answer, which is not seated in the same row. 23040. Okay. If I'm going to do this manually, like, okay, I put X here and then I put Y here, then I permit it, it's going to take a very long time. Okay, and yeah, I'm going to end with this. Okay, question B is probably, it is, the beauty of it is in its simplicity lah. Okay, dia punya kesenangan sebenarnya itu adalah satu keindahan. But the problem is, in order to achieve that simplicity, we need to like think like all these inception levels of thinking now. Okay, it is tough. It is very tough. I purposely choose to answer the most difficult question out of the questions in the textbook. This took me a very long time. Okay, I just want to let you know that this took me a long time to figure out because I was so busy trying to figure out, oh, kalau saya letak X sini, Y sini, macam mana permutate. Lepas tu saya letak X di bawah, Y di atas, macam mana permutate. When actually, the beauty of it is, if you think logically, there are only two situations. Either diorang duduk bersama-sama, no, either they are sitting in the same row or they're not sitting in the same row. We don't care whether they're seated together. Okay, either same row or not same row. Okay, so so yeah, that's the. If I were to add a question D lah, kalau saya mau tambah satu question D I will find the number of arrangements of seating these 8 persons such that X and Y are not seated together. Yeah. So if seated together is 8640, not seated together will be 8 factorial minus 8640. And that's your answer. Okay, so yeah, so that's permutation for you. Okay, permutation compared to the next part, which is combination. Combination is a little bit easier. Okay, permutation is difficult because the arrangement matters. Okay, the arrangement matters. How you think is also very important. Okay, so if you want to answer more textbook questions, I want to recommend lah. Okay, I want to recommend. Question 32 is difficult. Okay, question 32 is difficult. It's so difficult that dia cakap dia sampai bagi hint lagi. Okay, for me, question 33, 34, and yeah, question 33 and 34 is quite simple. You should be able to answer question 33 and 34 quite easily. I would suggest if you want to give yourself a challenge, answer question 33 and 34 first, and then try question 32. Okay, the answers are at the back of your textbook, so so I won't give it to you. But question 32 is actually very interesting. Okay, you can find numbers of greater than 5,000, and after you find out how many even numbers there are. Okay, it's interesting. It takes a while, but it's good practice for you. Okay, and one last thing before we end. So your work for today, okay, your work for today is to finish up from page 4 to page 7. Okay, everything that we've covered today is in page 4 to page 7. People, this is going to take a long time to complete. Partially because you know, you have to think a little bit more logical. And of course, it doesn't help that some of these answers are not correct. Okay, yeah, I'm very sorry for this. I will I will double check these answers again. Some of these answers are not correct. Okay, so yeah, it makes it all the more worse. Okay, but don't be so worried about the answers. Okay, think about the thought processes a lot. Okay, so I think that's it for today.